A 10 microfarad capacitor is charged by a 30 volt AC supply and then connected across an uncharged 50 microfarad capacitor. We need to calculate the final potential difference across the combination and the initial and final energies. How will you account for the difference in energies? Okay, so the first question, let us first write all the data as provided here. Okay, now a 10 microfarad. So let C1 be equal to 10 microfarad, and 10 microfarad will be 10 into 10 raised to minus 6 farad. That is C1. C2 is we are having 50 microfarad, and that will be 50 into 10 raised to minus 6 farad. A 10 microfarad capacitor is charged by a 30 volt, that is V1, and then connected across an uncharged 50 microfarad capacitor. So V2 is 0 volt. We need to calculate the final potential difference across the combination. Okay, first is so the final potential difference across the combination means we have to find the V common. Okay, we have to find the V common, and V common is equal to, what is it? It is equal to total charge by total capacitance. Total charge is C1 V1 plus C2 V2 by C1 plus C2. This is the V common. Okay, on substituting the value, C1 is 10 into 10 raised to minus 6 into 30 plus C2 50 into 10 raised to minus 6 into V2 is 0. C divided by C1 plus C2. From here 10 raised to minus 6 can be taken as common. So 10 raised to minus 6 into 10 plus 50. That is equal to, this is 10 raised to 1 into 10 raised to minus 6, that is 10 raised to minus 5 into 30 by, this will full become 0, by 60 into 10 raised to minus 6. 0032. So the common potential will be, V common will be 10 raised to minus 5 plus 6 by 2. So that is 10 by 2, 5 volt. So the common potential, V common, the final potential difference across the combination V common will be 5 volt. That is the first question. Second question is to find the initial and final energies, and how will you account for the difference in energies. So second one is to find the initial and final energy. So the initial energy, I am representing the initial energy as Ui and final energy as Uf. And U here is the energy. So for initial it is I, final it is F. Okay, so Ui is equal to, we have different formulas for finding the energies, and from there I'm choosing half CV square. Okay, so we are going to use ui equals half CV square. Okay, and here it is going, I'm going, since it is the initial energy that we are finding, we are going to take the first capacitor. So C1 V1 Ui is equal to half C1 V1 square, which is equal to half into C1 is 10 into 10 raised to minus 6. So 10 raised to minus 5 into V1 is 30 volt. 2 into 15. So UI is 15 into, sorry, I made a mistake here, into again 30. So 15 threes are 45. So 45 into 10 raised to minus 4 joules. This is UI, U initial. Now U final is equal to half CV square itself. Since it is a final, we will need the C2 will take. Will we take C2? No. That is where the problem comes. Here, we are going to take the total capacitance. C effective we will be taking. C effective. For V square, we found the potential difference. See, V common we will take for V square. V common. So UF final energy will be half C effective into square of V common. Now we have to find C effective. We don't know C effective. What is C effective? C effective is C1 plus C2. C effective is C1 plus C2. C1 plus C2 is 10 into 10 raised to minus 6 plus 15 into 10 raised to minus 6. That will be 60 into 10 raised to minus 6. 60 into 10 raised to minus 6 farad. This is the total effective capacitance. We will substitute this here. So from there, UF is equal to half into 60 into 10 raised to minus 6 into V square, V common square. That is 5 into 5. So 2 30s. So it will be 25 into 3 into 10 raised to minus 5. 75 into 10 raised to minus 5 joules will be UF. Okay, so UI is the initial energy. This is the final energy. How will you account for the difference in energies? Right? So now, so we have found the second one also, the initial and final energies. The next question is, how will you account for the difference in energy? Now, the difference in energy. For the difference in energy, that is U final minus U initial. U final is 75 into 10 raised to minus 5, right? And U final is 45 into 10 raised to minus 4. And this, for making the calculation simple, what I'm going to do is, this instead of writing it as 10 raised to minus 4, I'm going to write it in terms of 10 raised to minus 5. So here it was 1 by half into 10 raised to minus 5 into 30 into 30, right? So 15 into 30 is, so this can also be 450 into 10 raised to minus 5. So that is how I'm going to write. Minus 450 into 10 raised to minus 5. So that would be equal. I made a mistake here. It is UI minus UF. Okay, we'll write it again. difference in energy, Ui minus Uf. Ui is 450 into 10 raised to minus 5 minus 75 into 10 raised to minus 5. So 450, so from there 10 raised to minus 5 can be taken out, and that would be 3 450 minus 75, which is 375 into 10 raised to minus 5. So this is the difference in energy. Okay, so that is all, right? The question is, how will you account for the difference in energy? So yeah, this is the difference in energy. You can take it as the third part of the question. So this is how it is done. So first we are converting it, first and foremost, convert the, if it's given in picofarad or microfarad, convert it to farad. And once it's converted to farad, we only have to find one of the potential difference is unknown to us. So V common will be find the final potential difference it is. So final potential difference means it is V common, and V common is, this is the equation, C1 V1 plus C2 V2 by C1 plus C2. After substituting, we got what is V common. We got it to be 5 volt. Now we have to find U initial, that is initial energy, and final energy. We know there are several formulas for finding the energy. However, since we are given with the capacitance and the voltage here, we take this half CV square formula. So here, for initial, since it's for U initial energy, we know it is initial, so we have to take the first capacitance and the voltage of the first capacitance, and then we found it, right? Then for U final, here it is final, so it is half total capacitance. Okay, we are going to take the total capacitance, C effective into V square, V common square. We are taking the final potential difference also here. Okay, so the total capacitance we have to find, and then we substitute it in this equation, and then we get it to be this. Now how will you account for the difference in energy? Difference in energy is 375 into 10 raised to minus 5 joules. Okay, so this is how we do this question. Hope it was clear to you, and if you have any doubts, please put in your doubts in the comment section. I will surely reply for you. Okay, thank you.